All right, so we're gonna pick up where we left off. Let me start over on this. So we just did the z-score of 85 and the z-score of 100. Now we're gonna do the z-score of 125. So if I have, first let's just think about 125. So 125 probably like right there, somewhere like that. So I know that's more than one standard deviation above my mean, but not quite two standard deviations. All right. So we have 125, my data point, subtract my mean, and then divided by 16, which is 25 over 16, which is so 1.5625. So that would be my z-score. One, all right, is positive, so I know it's above the mean, and then it's telling me it's about 1.6 standard deviations above the mean. All right. So the scores on a psychology exam are normally distributed with a mean of 67 and a standard deviation of 8. What is the standard score for an exam score of 55? All right. I prefer to go ahead and draw a little picture. I think you should do this more and more often so you really understand what you're talking about. So we have, I know that's ugly, but 67, right? The mean of 67, standard deviation of 8, right? So if I go one above 67 plus 8, 75, right? 75 plus 8, we got 83. 83 plus 8, 91, right? If I go down 3, 67 plus, or subtract 8, 59, subtract 8 again, 51, and then subtract 8 again, 43. All right. Now, we're trying to figure out the standard we're trying to figure out the z-score or the standard score for a grade that is, I don't know why I was doing this. For a grade that is 55, right? 55, about right there. So I know just from looking at it, I know we're about 1 and probably 1.5 standard deviations below our mean. So my z-score should be about negative 1.5. All right, I know that should be close to it. You don't just want to take whatever your calculations are and take it as the truth. You want to think about it and make sure that you're not just plugging stuff into a formula blindly. All right, so let's see. So my z-score is equal to my data point, 55, subtract my mean, 67, divided by my standard deviation, 8. 55 minus 67 is negative 12, divided by 8. And that's what I get, man. Right on the money. Negative 1.5. So most of the time it's not going to happen out so perfectly. When I look at it and say, that's what it is, I got to do the computation because I didn't have confidence that was the answer. But then I got my work and I see, yes, that is the answer. All right, so let's get a little deeper. The standard, here is a list of the standard scores and the percentiles. So let's the percentile, all right, percentile of the data is the percentage of all data values in the data set that are less than or equal to it. So, if you're thinking about the normal curve and you say, right here at the mean, the mean is the 50th percentile. So what would be the z-score for the mean? The z-score for the mean would be 0 because that's how far away you are from the mean. And we see that for a z-score of 0, 50% of the values are below it, right? What about if I go 1 standard deviation above the mean, right? So that'd be the mean plus 1, right? Or let me just say the z-score is 1. Z equals 1. We're talking about 1 standard deviation above the mean. Well, look, in the empirical rule, I know if I go 1 below and 1 above, that's 68% of the data. So this is 34% and this is 34%. Well, if I'm 1 standard deviation above the mean, then all the data that's below me would be, that 68%, but plus the rest of this as well. Or you could say 50%, half, right? This half, and then plus 34%. So that would be a z-score of 1 means you're in the 84th percentile. That means 84% of the data lies below that, right? So 1/84th percentile. Let's do one more, right? I'm going to erase this. I don't understand why all that stuff is there, but I'm sure it has something to do with this Apple Intelligence crap. All right, let's do this again. So we got a normal curve. I'm going to have to draw it condensed up. We got our mean, right? The mean right here. Let's say I go 2 standard deviations below. So the z-score would be negative 2, right? Negative 2. That means 1, 2. Now I know if I go 1 above or 2 above and 2 below, that would create, from the empirical rule, that tells me 95% of the data. It's really 95.5, but we're just going to call it 95. Well, that means what's left of the data is 5% because all the data has got to be 100%. That means 2.5% is here and 2.5% is here, right? So my z-score of -2 means I'm right here. 2 standard deviations, I'm going to do it in red. 2 standard deviations below the mean. This means that I'm in the 2.5th percentile because only 2.5% of the data lies below that. So if we go to -2, yeah, maybe it's not. Maybe it's 95 point, I don't know. They approximated it as 95. So it's not perfect. This z-score gives you the exact, but the empirical rule is not perfect. But we see it's about that, right? So hopefully you get where I'm coming from. Let's look at one of these. Cholesterol levels in men 18 to 24 years of age are normally distributed with a mean of 178 and a standard deviation of 41. In what percentile is a 20-year-old man with a cholesterol of 190? All right. So in order for me to figure out the percentile, I need to get a z-score. All right. So I need the z-score before I could tell you the percentile. So we need the z-score. Z is equal to the data value. So his cholesterol is 190. Subtract the mean. It tells me the mean is 178. And then divided by the standard deviation, which is 41. All right, 190 minus 190 minus 178 gives us 12 divided by 41. we see that this z-score is 0.29, I'm going to just say 0.293. So the z is equal to 0.293. That means that he is 0.293 above the mean. So up here, I go and find that z-score, and I get as close as I can to it. The z, obviously, I'm not going to be able to get right on because there would be too many values for me to be using this chart. But 0 is here, 0.2, all right? I see that it's somewhere in here. 293, I'm going to just call that point. Whoop, that's a little bit further, right? That's somewhere here. I'm going to just call it approximately z is equal to 0.3, right? So we're saying 61.79% of the data lies below that, right? And if we look at that on a normal curve, I'll just sketch it out real quick, right? Our normal curve is, and this is from here to there is 1. So plus 1 standard deviation plus or minus 1 standard deviation. So we're saying we're just going up 0.3. So maybe like this much. So plus 0.3 standard deviations. I'm saying that if I take this, right, I know that right in the middle and down is 50%. So I'm saying from here down is, in this case, 61.79%. So that means, from here down, in this little gap, there's 11.79% of the data, which that tracks with what I've been talking about. So do you have to have all the little pictures? Nah, but it gives you a good idea. So we're in the 61, I'm going to say 61.79 percentile. Let me say 9th percentile. And that's another way of saying 61.79% of the data is below me. Or we could say that, if we look at this 11.79%. So if you check your cholesterol and you're saying, well, doctor, is that normal? And he says, well, you're in the 61st percentile. What does that really mean? That means that average person has 50 percentile, right? So you're above average. Your cholesterol is 11.79% above average. Is that good? Well, you want to be, lower cholesterol levels. So it's not great, but it's not terrible either because you're pretty close to average. You're above average, but having a high cholesterol isn't a good thing to be above average in. So doctor would probably say, bro, eat some Cheerios for breakfast. Stop eating all that bacon and them biscuits. Eat some Cheerios and some eggs, my friend. All right. So what cholesterol level corresponds to the 90th percentile? So to the 90th percentile, let's kind of look at that. Now, let's kind of look at this last question. It says, in what percentile is a 20-year-old man with cholesterol of 190, right? So it was asking about the percentile. We needed the z-score, and we had the cholesterol level. Here, it gives us the percentile. We need to find the z-score once again, and then we can figure out the person's cholesterol level. So if I'm just looking at the normal curve and I'm thinking about, where is about this at? I know if this is the mean, well, there's 50% below the mean. If he's in the 90th percentile, then I know if I go 1, 2 above the mean and 2 below the mean, we're talking about this is from here to here is 95% of the data. So if I think about, all right, that means there's 2.5% here and 2.5% here, right? I can say that this span right here is 95 divided by 2, 47.5, right? So if I'm thinking about 90%, I'm saying I want to go above 50%. That's 50%, but then I'm going 40 more. So I'm not quite going 2 standard deviations. I'm going a little bit less than 2 standard deviations. And we're going to say this would be another 40%, and this whole thing would be, the 90th percentile. So I'm thinking it's going to be about 1 point, maybe like 1.5 above the mean, 1 point something above the mean. Let's kind of look into it. That's just me kind of thinking about it. You want to make sure you're thinking about this. All right. Watch how we do this. So it gave me a percentile. From that, I can get a z-score. How do I do that? Well, I can go to this sheet. Percentile is 90th. I'm going to get to the closest percentile I can get to. That's 1.3. All right. That was pretty close to my estimation of, about 1.5. So 1.3 is my z-score. So this is z-score is 1.3, approximately, right? We can't get it exact off of this table, but pretty close. So now let's think about what my cholesterol. Well, I know to compute a z-score, I'm taking, my z-score is equal to my data value, subtract the mean, divided by my standard deviation. So I use that. And I know that 1.3, my z-score is equal to the data value, subtract the mean. Well, I know the mean is 178, divided by the standard deviation, which is 41. So I'm just trying to solve this equation for x. First thing I need to do is get rid of that 41. So I multiply by 41 because it's dividing. I'm doing the opposite. Multiply both sides by 41. That cancels out. And I got 1.3 times 41 gives me 53.3. And that's equal to x minus 178. So I add 178. And I get x is equal to 231.3. So, my friend, your cholesterol levels are about it's approximately 231.3 is your cholesterol level. Cholesterol level. Is that good? Nah, that ain't good, brother. You got some high cholesterol. 90% of people have lower cholesterol than you, right? You need to lower your cholesterol. Your cholesterol is, quite a bit above the mean of 178. What we want to see is about 178 or lower. So you also need to eat some Cheerios. Don't be getting them honey nuts. Just get the original, my friend. They ain't going to be good, but it's going to do your body good. All right. The heights of American women ages 18 to 24 are normally distributed with a mean of 65 inches and a standard deviation of 2.5 inches. In order to serve in the U.S. Army, women must be between 58 and 80 inches tall. What percentage of women are ineligible to serve based on their height? So let's start it out. right? Go ahead and kind of draw a curve. So a mean, yeah, let me get it a little bit further. Right, so the mean, right in the middle of 65 inches, and then a standard deviation of 2.5 inches. So, this right here would be 62.5 inches. Then we got 60 inches, and then we got 57.5 inches. We go up. One would be 67.5 inches, and then two would be 70 inches. I'm sorry. And then 72.5 inches. All right. What percentage of women are ineligible to serve based on their height? So we're looking at from 58 to 80 inches. So from 58, that's a little bit above that. And then to 80 inches, that's way above that, right? So all these people can serve. Well, let's think about this real quick. Go back to I would go back to the empirical rule. Empirical rule is like the bread and butter of this, right? That's what you should first start with. And then if that doesn't help you, you can go into your Z-scores. And we could figure it out with the Z-scores. And we're probably going to have to, honestly, because we don't have, 58. Or I'm sorry. Oh, man, I said, yeah, 58. So 58 is right here. And then 80 is way up here. So 58, we need to figure out the Z-score for that. I know it's 1, 2, almost 3 standard deviations below the mean, but we need to figure out exactly. So here's how we figure that out. We know the Z-score is equal to the point. So 58, subtract the mean, 65, divided by the standard deviation, 2.5. All right, so 58 subtract 65 divided by 2.5 gives us negative 2.8. All right, so that means that 58 is 2.8 standard deviations below the mean. So almost all people can serve in this. All women can serve, but not everybody. Let's go to this. So 2.8 below right here. So that means the 0.26 percentile. So how many people are ineligible? Well, how many people are ineligible? Only 0.26% of people. So only 0.26% of not just people, but women are ineligible. All right. Well, why didn't I do anything with 80? Well, let's look at this real quick. All right. So I see at 3.5, that's when it's like most of the data. They don't even bother going up much further. But we're at 1, 2, 3 standard deviations. And then it would be 4 standard deviations, right? And then 5 standard deviations. And then another, so we'd be 6 standard deviations above the mean before we cut off. So, hey, I'm saying that all the data above the mean is covered because 80 covers it all, right? Because, 3.5 standard deviations basically covers it all. But if not 3.5, then 4. If not 4, then 5. And then we're saying this is 80 is actually 6 standard deviations above the mean. that for sure covers all the data. The table doesn't even give you any much more than that, or it doesn't even go that far. So it doesn't go to 4 or 5 or 6. But if it did, I mean, how much closer do you want to get to 100? Maybe this is 99.999, and then this one right here is 99.999999. At what point are we just going to say that's all the data? If you're taller than that, you an anomaly. You an alien. All right. Hopefully that makes sense to you.